In this video, we're going over binary tree right side view. So given the root of a binary tree, imagine yourself standing on the right side of it. Return the values of the node you can see ordered from top to bottom. So in our first example, we're given this tree and then we're currently standing on the right side and then we're looking to the left and we can see we have the nodes 1, 3, and 4 because these are the first node at each of the levels. Let's go over the thought process. So let's first go over the traversal. Let's go over the pre-order traversal. In the pre-order traversal, the direction is the roots and then the left subtree and then the right subtree. This means we're currently staying on the left side of the tree, but we want to stand on the right side of the tree instead. So we can implement a modified pre-order traversal. So instead of going the usual direction, we're going roots and then right and then left. This will allow us to stay on the right subtree before we visit the left subtree. Now the next part is, how can we determine the current node X is the first node at the level? This is because we're currently traversing to the rightward. We want to take the first node that we visit at each of the levels. So we can keep track of the current level Y. If our current list of node values has Y elements, this means this is the first node at the level. This means X is the first node. X is the first node at the level. So for example, we're currently starting from here, and our resulting list currently is equal to 0. And this is currently level 0 here. So we check the level, and then we check the size of the list is currently equal. This means this is the first node we have visited, so we can add the current node value to our resulting list. Same thing here. So after we get to this level, this node here, the current size of our list is equal to 1. And this level here is also equal to 1. This means we have yet visited this level. So this is the first node. So we can keep track of the current level as we move downward. So let's go over the pseudocode. So we're going to create a list results to keep track of the node values. Then we're going to implement the modified pre-order traversal. Then what parameters do we need? We need node, the current node we are visiting, and then results, the list of all nodes, or the list of resulting nodes. And then we also have the level, the current level, initially 0. Then what's the base case? If node is equal to null, there are no values here. We can just return from the recursive call. Then each of the recursive call, if level is equal to result.size, this means this is the first node at the level, and we have yet visited this level yet. So we can add node.val to results. Then we're gonna recursively traverse to the right subtree because we want to stay on the right side of the tree. Do not forget to increment our level. And then we're going to recursively traverse to the right side, to traverse to the left side. Then we can return the resulting list. Now let's go over the time and space complexity. For the time complexity, we get O of n, where n is the number of nodes. Visit each node once. In our space complexity, we get O of h plus O of h, where h is the height of the tree. This is because of our recursive call stack memory and our resulting list. Now let's go over the code. So we're going to implement the recursive approach, recursive pre-order traversal. We're going to create our list results. Then implements our pre-order traversal, or modified pre-order traversal in this case. Let's go over the base case. If node is equal to null, this means there are no values here. We can just return from the recursive call. Then we'll check if the current node is the first node at the level that we have visited. If level is equal to result.size, this is a new level, so we want to add the current node value to a resulting list. Then want to recursively traverse to the right subtree first. This will allow us to stay on the right side of the tree. Make sure to increment our level by 1, and then we're going to recursive traverse to the left side. Let me know if any questions in the comment section below. Like and subscribe for more videos that will help you pass the technical interview.